Okay guys, so what we're going to be doing today is we're going to be looking at how to factor polynomials, but for the purpose of finding x-intercepts. We've already done factoring, so the factoring portion of this video is going to be done very, very quickly. Your goal right now is to learn what that means to find x-intercepts and how factoring can help us do that. Okay, so to start off here, we're going to talk about what is an x-intercept, because that's a new concept for some of you. Well, first off, let's look at a y-intercept. A y-intercept we looked at many, many times, and what that is where the line hits the y-axis. Okay, this is the example right there, and what you may remember is it always has the form 0, comma the number. Well, let's think about what the x-intercept would mean. If the y-intercept means it hits the y-axis, the x-intercept would mean it's where it hits the x-axis, which is right there. Thinking about the point, that now, okay, so this is your 0 for x, that's why it's 0 in every single y-intercept. This horizontal line is your 0 for the y, so that's why it will be, in this case, negative 5, comma 0, but every x-intercept will always be of the form some number, comma 0, because it's always hitting the line when y is equal to 0. The key here is to think about the fact that y is equal to 0. So, going back to this process again, what I'm going to say here first to start off is, how would I find the x-intercept at this point right here? We know the y-intercept is 6. Okay, that's something we've done. Now what you're not thinking about is the fact that the reason that works is because you're plugging in 0 for x, because the point is 0, comma 6. What we're looking at here is, if we want to talk about a x-intercept, is we need to look at plugging in 0 for y. Okay, because now every point, as we talked about, is of the point, every x-intercept will be of the point something, comma 0. And remember, that is your y part of the point. So if we're looking at it that way, that it leads to substituting in a y every single time. From there, the arithmetic's pretty easy. We would subtract 6 from both sides, which would leave us with x equals negative 6. And we could then write our point as negative 6, comma 0, because every x-intercept will be of the point something, comma 0. So pretty simple. All right, let's extend that to another example here. Kind of think this one through on your own. You don't have to write it down, but just think it through. So again, because it's an x-intercept, we're going to start off by plugging in a 0. We're going to add 8 to both sides, and we end up with x equals 8. Writing it as a point, we get 8, comma 0. Now, I'm guessing some of you have noticed, hey, wait a second, I just took the opposite of negative 8. And that's true for the problem like this. That is what you'd end up doing. Okay, we're going to take it a little bit further, and we're going to look at a two-step equation. That was just a one-step equation. The process is the same. We're going to set it equal to 0, and we're going to go ahead and solve it. A lot of people freeze up here. They realize, they think with a 0 they don't know what to do. Well, if the problem was 3x plus 2 equals 8, you guys would know what to do. You would subtract 2 from both sides. You would divide by 3. And you get your answer. And this is something we've practiced since, I don't know, at least 6th grade, probably, even earlier. So don't be scared by the whole 0 piece. All that really does is mean that whatever you subtract, that's just what you get. So in this case, I'm minus 2, so I end up with a negative 2. And then I divide by 3 on both sides, and I end up with x equals negative 2/3. So as you can see, you end up with x equals negative 2/3. Okay, again, I want you to look for patterns here. Some of you may be noticing there are certain little patterns that can make this problem easier for you. Such as, I've had students notice before that all you're really doing here is you're taking the opposite of x, which is negative 2. So the opposite of that part, opposite of the plus sign, and then dividing by the number in front of x. And that's something that a lot of people have done, in class. So that's a pretty smart little shortcut to do. Okay, so let's try that again on this one. See if you can do this one kind of on your own. Okay, so some of you may have tried to use that little shortcut we did, which remember is to sort of take the opposite of this number and then divide by the thing in front of x, which would be negative 5 over 2 when you simplify, because you can't leave a negative on the bottom, which is cool. That's a great shortcut. It works. But it's also fine just to be able to set it equal to 0 and solve the equation. Adding 5 to both sides, and then, of course, dividing by negative 2. The reason it works is because those are the steps you do anyways. So as you can see, we end up with those steps, and we end up with negative 5 over 2. So here's sort of the next question. How would I do something like that on a problem like this? Okay, how would I do this? And that's something to kind of think about, because this is where we're taking it to the next level. Well, some of you might think to yourselves, okay, well, I'm going to go ahead and set it equal to 0 just like before. And then you might think, okay, well, let's see, last time I subtracted 12. Subtract that number. Then I'm not really sure where you go from there. Would you maybe divide by x or divide by 8? Well, let's try dividing by x. That's going to leave me with negative 12 over x equals x plus 8, okay? Because the x squareds, and I don't know what to do from there. Maybe minus 8 now, or I don't know. So I really don't know where I can go from this. In fact, no matter what I do algebra-wise, I'm not going to get anywhere. Because the problem is I don't really, I don't have a way to solve an x squared problem. That's the real issue. But what I do have, and this is where it comes into what we've been doing, is I have a way to take this problem here and turn it into two factors, because that's what we've been doing in class. If I do that, there's a special thing in math called the zero product property. What that means is, basically, if one of these things is 0, I don't even care. This could be 1,000. But 0 times 1,000 is, of course, 0. Okay, same thing is true if this could be 72. But if this is 0, then the whole thing is 0. And that's a really cool quality that we're going to use to our advantage when we do these problems. Because all I have to do is factor this problem, and once I've done that, it'll create easy problems for me to go ahead and simplify. And each individual piece could be set equal to 0. So it's called the zero product property, and what it says is it doesn't matter how many things are multiplied together, if one of them is 0, the whole thing is 0. So let's take a look at how we would solve this problem. What we're going to do is we're going to factor it, because this is the one thing we know how to do with these sort of problems. So as I do this is all familiar to you guys. Again, this part's going to go pretty quick. The factors will go in there, and what I'll do is I'll end up with x plus 6 and x plus 2. But the difference now, that's different than what we've done before, is now we're saying this is when it's equal to 0. Normally that works for every possible value of the parabola. So x plus 6 times x plus 2 could be equal to maybe 14 or 16 or whatever we want. And we can test when it's equal to that. This is specifically when it's equal to 0. The advantage to that now is I can look at these two pieces, and all I really need is when one of them is equal to 0. So I'm going to take a look at just these two pieces. Now remember, using the zero product property, I don't have to have both of them equal to the same time. There's no x that would make that make sense, because when I plug one in, the other one doesn't make sense. So what we're going to do is we're trying to find what either makes this 0 or makes this 0, because if one of them's 0, when they're multiplied, the whole thing will be 0. So what I'm going to do now is I'm just going to look at each piece individually. I'm going to say, all right, well, what about the left side? Or what about the right side? I'm going to solve it. Now, if you think about what we just did, we learned some tricks. We could take the opposite of 2, or the opposite of negative 2. So what happens is I'm subtract 6 and I get negative 6, and I'm subtract 2 and I get negative 2. Those are now my x-intercepts. Why? Because when I plug a negative 2 into this one, negative 2 plus 2 is 0. Over here, 6 plus negative 2 is 4. But that doesn't matter, because 0 times 4 is 0. If I do the same thing, I plug in negative 6 on the right side, I'm going to get 0 here, and over here I'm going to get negative 4. But again, doesn't matter what that number is, because negative 4 times 0 is 0. The last step, just like always, is to write both of these as x-intercepts, because we're talking about points on a graph, so we want to write those as a point. So what we're going to do is we're going to look at a few more examples. I'm going to look at a few more examples, and we're going to do these pretty quick, because this is not for notes, this is review for the final. So what we're going to do is we're going to go ahead and say, do our problem like normal. We're going to check for a GCF. There's no number that goes into 2, -9, and -5, so we're good. And we're going to set the problem up like normal. We end up with -10 on top, -9 on the bottom. And I'm going to go quickly to the point where we have our intercepts, because this is something you guys can do by now. Now, we're going to go ahead and set this up and set each one equal to 0. Now remember, what we had learned in the last video, earlier today, on just setting equations equal to 0, is there are some shortcuts. So for example, some of you probably remember that this is going to be 5, 0 automatically, because you just take the opposite of negative. Over here, because this one was a two-step equation, the shortcut was to take the opposite of this and divide it by the number in front of x. So you're probably realizing that you're going to end up with -1/2, 0. But we can go ahead and solve those as well. But I have no problem with you guys picking up those shortcuts and figuring some stuff out. Okay, and I have no problem with you guys noticing those shortcuts and using them to your advantage. Okay, looking at the third example here. Hopefully you guys, now notice I used the word roots. That's because x-intercepts, roots, and solutions basically all mean the same thing. When I say solve a problem, it would be equal to 0. When I say find the x-intercepts, it is equal to 0, but they might not put that because you're supposed to know you set it equal to 0. And same thing for roots. Roots mean the place where a graph hits the x-axis. Well, those are the x-intercepts. So here, the GCF is 5, so we need to factor out the GCF. Remember, just like before, that makes the problem a lot easier. We're going to go through the steps, find our answer, which is a pretty simple process. Okay. Now here's the deal. What you really want to look at is you want to look at each one of these equal to 0. So the question is, you got 5 equal to 0, you got x plus 4 equal to 0, and you got x plus 3 equal to 0. You have to look at every single factor. However, the first one makes no sense. Can 5 equal 0? No, that makes no sense. So 5 really doesn't matter in this problem at all because it doesn't affect what makes it 0. 5 can't be 0. 5x could, because you could put 0 in there, but not 5. So we're just going to only look at those two examples that are important to us. Subtracting from both sides or using the shortcut, we end up with -3 and -4 as our answers. And this is the last one we're going to look at for today. As you guys can see, we have a bit of a weird example here because we have x to the third. If you remember from our GCF problem, you always want to divide out that 3 to start that extra x to start out the problem. Okay, now from there we're going to factor only the stuff that's inside the parentheses, and the problem becomes a pretty simple problem from there. And we did this exact same one in the factoring GCF. So if you want a better explanation, you can go back to that one. Now, just like before, we have to look at what makes each piece of these three things equal to 0. However, this time, can x equal 0? Sure, x can equal 0. It's when it's equal to 0. So we can solve the other two, but in reality, what happens here is we end up with 3 solutions. Because unlike with 5 equal to 0, I can just go ahead and plug in a 0 there, and it works. When x is 0, that's true. Okay, so therefore, there's going to be 3 answers. So this is the one thing to watch out for on this, is when you have an x to the third, that means you're going to get 3 different x-intercepts or roots or solutions. They all mean the same thing. Okay, so hopefully that helps you guys out with how to find x-intercepts. Obviously we've been doing this all year, but the key is to set them equal to 0. There's some tricks you can use and stuff, but it's all what we've been doing. The difference is at the end, you set it equal to 0.